Spot check on the first one. Square root of 81. 9, right? Okay. Because we could break this down if we didn't see that 81 was a perfect square. 9 and 9, there's my pair. I'm looking for 2 because my index is 2. Okay? Alright? Square root of 12. I love 2 times the square root of 3. Okay? Now, on this one, we've got a couple of different ways that we could do it. We could break 12 down like we did in the last one. 12 is 3 times 4. 4 is 2 times 2. Since I'm looking for a square root, there's my pair. So that 2 breaks out. Okay? The other ones stay inside. Okay? Or we could write the square root of 12 as the square root of 4 times the square root of 3. And the square root of 4 then is 2. Okay? So either way like that, we get 2 square roots of 3. Okay? Anybody get the square root of 32? If not, do the rest of those like we just did 1 and 2. So if I'm looking at the square root of 32, if I break it down, that's going to be 2 times 16. 16 is 2 times 8. 8 is 2 times 4. 4 is 2 times 2. So I've got a pair here. So that one gets broken out. I've got a pair here. That one gets broken out. So then this would be 2 times 2 times the square root of 2, or 4 square roots of 2. Okay? If I'm looking at it the other way, the biggest perfect square factor in 32 is 16. And that leaves me with 2. And then that one becomes 4 times the square root of 2. Either way, there's the answers for the first 3. Okay. Second 3. 3 times the square root of 20. Well, now I could do 20 and then multiply that end result by 3. But in this case, because there's a number out in front, that's going to come along for the ride. And 20 then is the square root of 4 times the square root of 5. Square root of 4 here is 2. So this ends up being 3 times 2 times the square root of 5, or 6 square roots of 5. Yeah. In terms of cube roots, or if we take it to the next level, fourth roots, okay? Now instead of looking for perfect square factors, I'm looking for perfect cube factors. And the perfect cube factor of 32 would be 8. So we get 2 times the cube root of 4. Now, if I were to do my breakdown here of 32, 2 times 16, 2 times 8, 2 times 4, 2 times 2, now I'm looking for groups of 3 because my index is 3. So then that would be the 2 would be broken out, and then these 2 make the 4. Okay. perfect fourths, what do you think a perfect four that goes into 729 is? From yesterday. Nine's not a perfect four. Does 81 go in there? Yes? What's the fourth root of 81? Three. What about the fourth root of 9? Do we like the fourth root of 9? Actually, we don't. What can we do with the fourth root of 9? What's another way to write 9? Let me rephrase the question. What's another way to write the number 9? What? 3 squared. So this is like, there it goes. This is like the fourth root of 3 squared, which is like what?
It's like the 3 over, or
3
exponent
squared to the,
2/4.
well, first, yeah, yep, you're going one step ahead. So this is like 3 squared to the 1/4 power. And then that makes 3 to the 1, or to the 2/4 power, right? Which is 3 to the 1/2 power. Let me extend that down a little bit. Okay. And what is 3 to the 1/2 power? Don't say 2 root. That was what you were going to say, wasn't it? 2 root 3 to the first power, right? What do we say instead of 2 root? Square root. Yeah, we say square root of 3. Square root of 3. So this is square root of 3. So my answer here is 3 square roots of 3. Okay. Now, on one of your homework problems last night, it was something along the lines of the cube root of, I'm just going to say negative 27. I don't even know what the problem was, but there were a couple of different ones in there. Okay? So, we're looking for, first off, we're looking for the third root, right? So that means I'm looking on my perfect cube list. Okay? Is 27 on there?
Yes.
Yeah. The cube root of 27 is 3. Okay? Now, the confusion that I saw earlier today, yesterday, and yesterday afternoon was the negative sign. Now, this negative sign is different than, I want to say it's number 15. Negative 3/4. Yep. Okay. Those two negative signs are different. Okay. This negative sign in the cube root of negative 27 means it's just a negative number. Okay. And so this answer here is negative 3, because negative 3 times negative 3 times negative 3 is negative 27. Okay. This negative sign, because it's in the exponent, that's when we move it to the top or move it to the bottom. We move it to the other side because it's in the exponent. So this one then would be 81 to the positive 3/4 power over 1. Bad one. Over 1. Okay?
That's just the answer.
Well, then now you simplify it. So you should be 27. Okay? Two different meanings of negative signs depends on where they are. Okay? In your textbooks now, on page 697, okay, we're going to talk about those properties of powers. Okay? You've seen most of these properties of powers before. Okay? You've used a lot of them before. I am not so much concerned about the name of the property, just that you remember how to use that particular property. Okay? I will most of the time refer to it by its name, okay? But you don't have to. We're not going to ask you, what's the quotient of powers property. Okay? But we expect you to be able to use the quotient of powers property. Okay? So, what the product of powers property says, that is, if you have the same base and you are multiplying, you can add the exponents. Okay? So, for instance, 3 squared times 3 to the 5th power is 3. Whoops. Now we. Whoa. 3 squared times 3 to the 5th power is 3 to the 7th power. I add those exponents. Okay? The quotient says that if you're dividing them, 3 to the 5th power divided by 3 squared, then you're going to subtract those exponents. So that would be 3 cubed.
That would be like 1 to the 3rd.
Because we're not dividing the actual bases. We're just subtracting the exponents. Because then in that case, everything would then be 1. Okay? The question came up earlier today, what if these are reversed? 3 squared divided by 3 to the 5th. What about in that case? So this then would become 3 to the negative 3 power, which would be 1 over 3 cubed. Okay? Still dividing, so when you're dividing, it's still top minus bottom. Okay? Power to a power. Okay, that's the one that we've been using the most, is power to a power. Okay? So if we had 7 to the 4th power raised to the 3rd power, that would be 7 to the 12th power. Multiply those exponents together. Product to a power just says if I have 2x squared y cubed and I take that to the 4th power, what that's saying is that 4th power needs to go in to all of the parts. It goes in to the 2, it goes into the x, and it goes into the y, but only in the exponent. Okay? Again, you've seen these before. This should just be a refresher. Okay? Quotient to a power, same thing. So now if I had 2x squared over y, and I take that to the third power, what that's saying then is this is 2 cubed x to the 6th over y cubed. That exponent goes in to all of the exponents inside what it's controlling. Zero power says anything to the zero power is 1. Okay? Negative exponent, we've been dealing with those the last couple of days. Move it to the other side, and that gets you what you need to. So, like 2 to the negative third power is 1 over 2 cubed. Okay? 1 over 2 to the negative third power is 2 cubed. Okay? Now, if you turn the page, okay, onto page 699, not 697 as it says up here, okay, but on page 699, what I'd like you to do now is I would like you to simplify those 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, those 20 expressions. I want you to simplify them. Okay? Using the powers that we just did. Go. Now, on mine, it jumps around a little bit, but they're all on your page. Just so you know. Okay? So you want to go left to right, top to bottom, or top to bottom, and then go to the right column. Left to right? Okay. 8 to the 0 power. 1. A to the negative 12th power, then to the 1/3 power. 1 over a to the 4th. Good on those two. Okay. Negative a to the 4th power. No.
Negative 1, 4.
No. No. This one's just a to the 4th. Think about it one of two ways. This is negative 1 times a to the 4th power, which is negative 1 to the 4th power times a to the 4th power. Negative 1 times negative 1 times negative 1 times negative 1 is positive 1 times a to the 4th is a to the 4th. Okay? Or, the other way of thinking about it, you can just do negative a times negative a is positive a squared, times negative a is negative a cubed, times negative a is positive a to the 4th. Okay? A squared squared. A to the 4th. Questions on those two? A to the 8th, b to the 4th, all to the 1/2 power. A to the 4th, b squared. 1 over a to the negative fourth. A to the fourth. Questions on those two? 1 over a squared, then squared. One over a to the fourth. A to the sixth divided by a to the sixth. No. 1. Anything divided by itself is 1. AB squared, quantity squared. A squared what? A squared b to the fourth. A to the negative fourth times a to the 0. One over a to the fourth. A to the negative fourth times a to the fourth. 1. It's really a to the 0 power. Whoa, tap the brakes, child. I double zero or double equal sign that one. B to the 12th divided by a to the negative 6th to the 1/3 power. No.
A squared b to the fourth.
A squared b to the fourth, not over. You don't flip the whole thing. Okay? This becomes a to the positive 6th b to the 12th to the 1/3 power, which is a squared b to the fourth. Don't flip the whole thing. Just move the negative exponent. Okay? B over a to the negative 2 power, then squared. Nope. A to the fourth b squared. Here again, this would become a squared b, then squared, which would be a to the fourth b squared. This is the second one. We just put it in there twice. Okay? Handle? Okay. So then, now, let's kick it up a notch. Let's simplify each radical. Okay? Now, I'm going to show you a couple of different ways of doing this. One way I like, one way it works, but I'm not a big fan of it. Okay? So I'm going to show you that way first. Okay? So, if I was doing this the first way, I would say, well, the square root of 16x to the 6th would be like 16x to the 6th to the 1/2 power. The square root comes with it 1/2 is the exponent of 1/2. By the way, if you haven't figured out that you should memorize that the square root is an exponent of 1/2, you should just memorize that. Okay? The cube root as an exponent of 1/3. Fourth root exponent of 1/4, etc. Okay? Memorize that. Okay? So this then would become 16 to the 1/2 power, x to the 6th to the 1/2 power. Right? Well, 16 is 4 4 squared to the 1/2 power. So that's just 4. And then this is x cubed. Okay? Not a fan of that method. Okay? But it works, switching it into exponent form, rational exponent form, and then doing it. Okay? The method that I prefer is, I prefer saying, well, this is the square root of 16 times the square root of x to the 6th. What's the square root of 16? 4. Okay? And now, I'm looking for, because I'm taking the square root, I'm looking for the biggest multiple of 2 that goes into 6. What's the biggest multiple of 2 that goes into 6? 3 is not a multiple of 2. 2 is not a multiple, or 1 is not. What's the biggest multiple of 2 that goes into 6? 6. Okay? 6 is a multiple of 2. Okay? So I'm going to divide 6 by 2. And that gives me x cubed. So my answer here would be 4x cubed. Okay? Now, let me show you one like the next one where it doesn't necessarily work out nice and pretty. Okay? So this would be -1, that's that part right there, times the square root of 8 times the square root of v cubed. Right? Broke it up into each and own and individual parts. Okay? Nothing that I can do with -1. It's going to come along for the ride. Okay? It's the Amora fish of our shark. Okay? Square root of 8. What can I do with the square root of 8? No. That's the square root of 12. What times what is 8? 4 and 2. So this is the square root of 4 times the square root of 2. Okay. What's the square root of 4? 2. Okay. Again, I'm taking the square root, right? So I'm looking for the biggest multiple of 2 that goes into 3. Or that's smaller than 3, I should say. 2 is the biggest multiple of 2 that's smaller than 3. So this would be the square root of v squared times the square root of v. What is the square root of v squared? No. It's just v, right? Because it's v squared to the 1/2 power, which is v to the 2/2 power, which is v. Okay. So I've simplified it as far as I can go. Now, OOII. Okay? Outsides get multiplied with other outsides. So, -1 times 2 times v is negative, oops, let me put that, is -2v. Insides get multiplied with other insides times the square root of 2v. Okay. If it were a cubed root, then I would be looking for multiples of 3 on my exponents and so on. Okay? You do numbers 3 and 4. So this would be the square root of d cubed times the square root of f to the 4th power. So this would be the square root of d squared times the square root of d times the square root of f to the 4th power. So this one is d, this one is f squared. So we get d f squared times the square root of d. Yes? Okay. Over here, this one would be the square root of h to the 4th times the square root of j to the 6th. So this would become h squared. This would become j cubed. So we get h squared j cubed.